Hello, Mumu, am I audible? Please just confirm. You can write in the chat box or you can use mic also.
चलिए वही करते हैं फिर आए अभी अभी इतना लोग आके बैठा रहे कि हमारा नंबर कब आएगा ये नहीं है हाँ, ठीक ठीक हाँ
Amit, I'm audible. Just please confirm.
Yes, sir.
Okay, okay, thank you. Slide is visible. Question number first.
Yes, sir.
Okay, okay, thank you. Let us wait for a few minutes. Maybe another participant will join, then after we'll start. Maybe 2 or 3 minutes. We'll wait. Okay, let us start. So the first question is in pipe. Let me just read all options. Yes. In network of pipes. The question number first for today. The week 9. In network pipes, first option, head loss in all the circuit is same. Head loss around each elementary circuit must be zero. Elementary circuit are replaced by equivalent pipes. None of the above. Which option will be correct for question number first? Please try to write your answer in the chat box. Everyone please try to write your answer in the chat box. For question number first, in network of pipe, head loss in all the circuit is the same. Head loss around each elementary circuit must be zero. Elementary circuit are replaced by equivalent pipe. None of the above. Which option will be correct? Okay, Amit is telling option A will be correct. Option A. Okay, other student please. Here we are not talking about the parallel and series network. We are talking about the circuit. Because if you will see the options, in all options the circuit term is written. So please think about uh, the circuit type of network. Then you try to write your answer in the chat box. So here actually the circuit means, let us suppose water is going in this direction like that. Like that. So this is the circuit. This circuit 1, circuit 2. So the question is here, in network of pipe, if you will see all options is circuit, the head loss in all circuit same. So actually such type of circuit, the head loss around each elementary circuit must be zero. The option B will be correct for this question. Now we'll move on the next question. Next question is, here you can see the detailed description. The basic pipe network analysis considers that the head loss around each elementary circuit zero. Just option written here. Okay. Now we'll move on the next question. Next question is, okay, when the pipe are connected in parallel, the total head loss, when the pipe are connected in parallel, the total head loss is equal to the inverse of the sum of head in each pipe is equal to the sum of loss of head in each pipe. Its same in each pipe is half that of in each pipe. Which option will be correct for question number 2? Please everyone try to write your answer in the chat box. For question number 2, which option will be correct? Anyone please just try to write your answer in the chat box. Okay, here question is asking about the parallel connection, right? Parallel connection of pipe and asking about the total head loss. So parallel connection means, let us suppose this is one pipe and here it is divided in two pipe. This is pipe 1 and pipe 2. Again one pipe. So this pipe and this pipe is parallel. Or you can think like that also. Not this one. Like that. Then it joined at a particular pipe. Then it go like that. So this is the first pipe, second pipe, third pipe, all three in parallel. So like that. In such case, your head loss, that is, let us suppose head loss in first pipe, head loss in second pipe, head loss in third pipe will be equal. That is HL1 is equal to HL2, HL3. If condition is if the diameter is same, that is the cross sectional area should be same. Okay. So which option will be correct? C option will be correct here. Okay, now we'll move on the next question. Next question is very important question. So which of the following relation may be used to replace a pipe of diameter capital D by a n parallel pipe, of diameter small d, So here you need to, let us suppose lot of parallel pipe is given, lot of, that is from 1 to n. You need to replace this by only a single pipe of diameter d. All diameter of the pipe is small d everywhere. Every pipe is same. Each pipe is same diameter. So just think on that. The condition of parallel pipe, that is the head loss condition, discharge condition, then you try to solve. You know Darcy's Weisbach formula already. So everyone please try to solve. Everyone please try to solve question number 3. Option A, D is equal to N capital D. Small d is option B, small d is equal to N by D capital. Option C, small d is equal to capital D divided by N raised to 0.25. And fourth one is option D is small d is equal to capital D divided by n raised to 0.4. So everyone please try to write your answer in the chat box. Question number 3. Here you have n number of parallel pipes. Everyone please try to calculate. I'll show you in the last how you will calculate or how you will think about to solve the question, but just please try to solve this question. You have 5 minutes. Very important question. Everyone please try to calculate and write your answer. Anyone please write your answer in the chat box. Whatever you have, try to solve with pen or copies, please. Very simple understanding required for solve this question. So if you have gone through your NPTEL video of week 9, very easily you can solve. Okay, let me solve the problem. Okay, here you know already the parallel pipe connection. Parallel pipe connection means what? I have already told you in the previous question. Like that. The parallel pipe like that. Another example like that. So similarly, you have the n number of pipe. Similarly, here you have the n number of pipe, that is, but discharge. The what is the relation in parallel pipe? Discharge will be distributed means your total discharge will be equal to in the discharge in each pipe, right? If n pipe here is you have, and all pipe have diameter small d, and you need to replace this n number of small d diameter pipe with a capital D. And head loss you already know. In each pipe head loss will be same, means HL1 is equal to HL2 is equal to HL3 dot dot equal to dot dot HLN. This will be same. So here we need to apply this one. So what is discharge? Discharge is nothing but your area into velocity. So similar thing I want to put here. So area pi by 4 if circular pipe, d square capital D into velocity. Let us suppose capital V. If the diameter is same, so area will be same, and if the number of pipe, let us suppose pi by 4 into a small d square into u, not square, only u, area into velocity. Similarly for Q2, similarly for Q3, all will be same. So that's why if the n number of pipes, so it will be n. When we will add, let us suppose only 3. So 1, 2, 3. If here n, so you need to multiply with n. Now pi by 4 will be cancel out. You have d square v is equal to d square un. So here you need only relation in D and capital D N. So you have to remove this one, capital V and a small u. How you will remove? Just see. You know already these things. The head loss will be equal, means the head loss in this pipe FL V square by 2G capital D is equal to FL V square by 2G small d. Here you just one thing you can notice, the head loss not depend on your diameter of the pipe, it's depend on material. What is the what will be the roughness of the pipe? So if the material is same, here the assumption is if the material is same for both, whatever you are going to implement, the capital D pipe and a small d, the material will be same. That's this is the assumption here. So if you will see, your capital V square divided by small u square is equal to capital D divided by small d. Here you have V square by u square. Here also you need to make this one. So you just square root both sides. D is V square is equal to small d square u and whole square. So here V square by u square is equal to small d square by u square, small d square by capital D square into n square. Is V square by U square is capital D by small d. Means capital D divided by small d is equal to D square divided by capital D square into N square. Let me write here. So capital D square is small, capital D by small d, not square, is equal to only the arrangement here. You need to just arrange the term. Then small d square small d square divided by capital D square N square. So now d cube divided by d cube is equal to N square. So something we are missing here, I think. What we are missing? So okay, FLV square by 2ZD, FLU square by 2ZD. Okay, V square by U square by capital D, that is capital D by small d. Okay, and here you need to put d by d at the place of square. So d cube by small cube and N square. Okay, we are, I think, correct. Okay, so here d is equal to small d will be small d cube will be d cube divided by N square, and d is equal to d cube divided by N square power 1 by 3. 1 by 3, 1 by 3 will be cancelled out. So d is equal to d, that is 3 will be cancelled out. So d divided by N to the power 2 by 3. I think we are doing somewhere mistake. Where I am doing? So pi by 4 into d square v. Okay, area into velocity n number of. So d square v d square u n. Okay, this is correct. So both sides square. Oh, here is square. So d to the power 4. Just if you will square this, d to the power 4. Here also 4. This is also will be 4. Okay. So this will be 4. This will be also 4. Means 5 to the power. Now it will be correct. Here 5 power 5. Everywhere 5. Here also 5. 5 will be cancelled out, and 2 by 5 means d is equal to capital D by N to the power 0.4. So option D will be correct here. So remember, please, you can also do the mistake like that in the calculation. So remember, please. Next question. Question number 4. The total energy line lie over the hydraulic gradient line by an amount equal to velocity head, pressure head, sum of velocity and pressure head, none of the above. Which option will be correct for this question? Everyone please try to write. Abdul, you are telling a option for question number 4, right? Yes, for question, yes, okay. Okay, we'll see. Other student, please also try to write your answer for question number 4. The total energy line lie over the hydraulic gradient line by an amount equal to so hope everyone got it. The question number 3, important question. Okay, let me discuss. Simple question, not. Yes, Abdul is correct, but how? Let me just discuss. So you know the Bernoulli's equation, that is the at a particular section your head will be same, means velocity head, pressure head plus velocity head and plus datum head will be equal. That is the means the total head will be constant, not equal. The total head will be the constant. So here the pressure head and your datum head, this will make your hydraulic gradient line. That is, for hydraulic gradient line you need to, let me just draw the pipe. If this is pipe, let us assume, and you want to see here hydraulic gradient line and here, that is the hydraulic head, hydraulic gradient line you want to draw between these two. So you need to check what, datum head as well as pressure head, not velocity head. Here also you need to check and you will draw the line. This will be your hydraulic gradient line. Now again I want to check your total energy line. Total energy line means what? Pressure, velocity and datum. Let us suppose here also I want to check. So your, due to the velocity, the head will be increased here also. So this is, so this line indicate your total energy line, right? And the distance here to here will be v square by 2g, and distance, and this one is your p by rho z plus z. So this is the concept. So here you can see the your hydraulic, that your total energy line is lie over v square by 2z above. Okay, so very simple. Now we'll move on the next question. Next question is question number 5. The hydraulic gradient line for a flow through a pipe is always below the total energy line, above the total energy line, above the axis of pipe, none of the above. The hydraulic gradient line for a flow through a pipe is always below the total energy line, above the total energy line. Just please, if you will just focus on the discussion of just previous question, you can very easily write the answer of this question. Okay, Abdul is telling A. Other participant also try to write your answer. Please, everyone please try to participate. Everyone please try to participate. because I have discussed just in question number 4. So everyone, please, everyone write your answer. Okay, let me discuss. So here the hydraulic gradient line for just I'll go with the detailed solution of question number 4. So here you can see your total hydraulic gradient line, this one, is below the total energy line. Hydraulic gradient line is below the total energy line. This was the question. The hydraulic gradient line for a flow through a pipe is always below the total energy line. A option will be correct. Yes, Abdul is correct for question number 5. Now we'll move on the question number 6. The loss of heat at entrance. Remember please, loss of heat at entrance of pipe in term of mean velocity of liquid in the pipe is 0.5 v square by 2z, v square by 2z, v square by z, and 0.2 v square by 2z. Entrance, remember please, entrance means the water is entering, that is inlet thing. Okay, so Bhavesh is telling A. Okay, for previous question also Bhavesh was telling A. Okay, good. So Abdul and Bhavesh telling option A is correct. Okay, for entrance. Okay. Other student, please also try to write your answer. For question 6, please everyone participate. Try to participate. Okay, let me discuss. So this is just based on experimental data. This the whatever the option will, maybe option A, B, C, D, whatever will be correct. These are based on experiment, not any the theoretical things here. So for entrance, remember please, your option B will be correct, that is V square by 2Z. Oh no, for entrance your answer will be correct, 0.5 V square by 2G. And okay, for exit also we have, for exit also I have the question. So at entrance level, so whatever your velocity head will be, that is the V square by 2G, that is a 50% of your velocity head will be lost. The meaning of 0.5, the 50% of the velocity will be lost at the entrance. Because of the eddies formation, you know already at the entrance level. Might be sir have discussed in the during the course instruction. Okay. So now we'll move on the next question. Question number 7. Okay. The loss of head at exit of pipe in term of mean velocity of liquid V at the pipe outlet is given by. Here the question is exit. Question number 7. So everyone please, okay, Bhavesh is telling B, Abdul also telling B. Other student please also try to write your answer. For question number 7. Okay, this is formula, not nothing for explanation here. So V square by 2G, yes, correct. You both correct. Question number 8. A pipe is said to be equivalent to another pipe if the length and discharge are same, length and diameter are same, velocity and diameter are same, discharge and head loss are same. Which option will be correct for question number 8? Please everyone try to write your answer in the chat box. For question number 8. The pipe is said to be equivalent. Here we are, the question is asking about the equivalent pipe concept, whether it should be length and discharge same, should be length and diameter same, velocity and diameter same, or discharge and head loss same. Everyone please think and write your answer. Everyone please. Okay, so let me just discuss. So equivalent pipe means you know already, but which option will be correct? Yes, discharge should be same. This is one criteria. Discharge should be same, as well as your head loss also should be same. The option D will be correct for question number 8. Question number 9. Darcy's-Weisbach equation is used to find the head loss due to sudden enlargement, sudden contraction, friction, none of the above. Which option will be correct for question number 9? Everyone please try to write. Okay, Abdul is telling C option. Option C for question number 9. Other student please also try to write your answer. Darcy's-Weisbach equation. Very famous equation in fluid mechanics. Especially in pipe flow it is very important. Darcy's-Weisbach equation. Anyone want to tell? The Abdul is telling friction. Okay. Okay. So yes, Abdul is correct. So actually Darcy's is back we use for your, that is a loss calculating using the friction of the pipe in case of pipe flow. 4FLV square by 2GD, or F dash I want to write here, FLV square by 2GD means F dash here is coefficient of friction and F is friction factor. So relation is F is equal to 4F dash. Remember, we have the question on this relation. So remember this. Now, the next question is the energy loss in a pipeline is due to surface roughness only, viscous action only, friction offered by pipe as well as viscous action, none of them. Yes, energy loss due to the both your viscous section as well as the friction offered in the pipe. Option C will be correct for question 10. Question 11. The entrance length is, what is the entrance length? Important concept. I have discussed also about the entrance length. The length in which the boundary layer remain uniform. The pipe length inside the reservoir. The length of pipe from its entrance in which the flow may be assumed irrotational, the initial length in which the flow develops fully such that the velocity profile does not change in downstream. Which option will be correct, please? Everyone try to write. Option C. Okay, Abdul is telling option C for question number 11. Other student, please also try to write your answer. Here we are talking about the fully developed flow, about the fully developed. The question is about the fully developed flow. The entrance length means at what length your flow will be developed from the inlet. So now please think on that and try to write your option. Which option will be correct for question number 11? Abdul is telling C. Okay, other participant also try to write your answer. Whatever you know, please, whatever you are thinking, you just write. Here is not your going exam, so don't worry. So anyone, please write your answer. Whatever you know. Based on your knowledge, whether A, B, C, D, which option is correct, doesn't matter. Just try to write your answer. Okay, let me just discuss. So I have also discussed earlier the previous classes. So let us suppose is a pipe and water is entering with uniform velocity here. The water is coming with uniform velocity and let us suppose in the way of water flow you have just put a pipe like that. As your velocity is, as your flow enter in the pipe, due to your viscosity as well as friction, the one boundary layer form like that from this side also, and it will reach up to the maximum limit. It will reach like that, not above. Let me draw very clear like that. Here also your boundary layer like that. After that, nothing. Here if you will draw your velocity diagram in case of laminar flow, that will be parabolic. Here also not change. Same diagram, the velocity profile. But once you will draw here, your velocity is varying like that. From this your also velocity varying. Here is velocity is constant. Here your velocity is varying up to that much. Here is constant. Here is your velocity is varying up to that much and then constant. So like that. So remember please. So this is the concept. So this is your entrance length. Up to that your velocity diagram developed. complete develop or not change. So if you will see the option D, the initial length in which the flow developed fully such that velocity profile does not change in the downstream. So this is your upstream and this is downstream. So in the downstream, as you will move, the velocity will not change. Velocity diagram. So hope you got it. Now we'll move on the next question. Question number 12. Okay, important question. So the head loss in sudden expansion. The head loss in sudden expansion. Remember please. The head loss in sudden expansion from 6-meter diameter pipe to 12. This is the 6 and now 12, like that. Here the diameter is 6. Here diameter is 12 centimeter. Here 6 centimeter. In term of velocity v1, that is here in pipe 6 is, you need to calculate the head loss. Here the question is head loss in terms of v1, that is v1 square by 2g, but how much here? Whether 15 by 16, 3 by 4, 1 by 4, 9 by 16. Which option will be correct for question number your 12? After this question, we have another set of questions for your 2023 NPTEL hydraulic engineering. So we'll solve also that question. So, but first you try to write your answer for question number 12. So first of all, you need to know the formula about the head loss due to the sudden expansion. If you know the formula, head loss due to the sudden expansion, you can easily write the answer of this question number 12. Okay, Abdul is telling D option 9 by 16. Okay. Okay. Beth is also telling D option. Okay. Other participant also please write your answer. Okay, how the answer, that is D or whatever, let us solve. So the formula you all know, that is the entrance That is option D is correct here, you know already. But the formula is this one. That is the same formula. Sudden expansion here, sudden expansion. So v square by 2z you already know. How we will remember? Here is velocity is v1, here velocity will be v2. So you need to write the difference of velocity because there two things is involved. How we will calculate the v1 v2 relationship? You know this one. Pi by 4 into 6 square v1 is equal to pi by 4 into 12 square v2. So you need the answer in terms of v1. So you have to calculate the v2 value here. So what will be the v2? V2 will be not square here, v2. Okay. So v2 will be 6 square v1 divided by 12 square, like that. Now you need to put here v1 minus 6 square by 12 square v1 whole square divided by 2z means 144 v1 minus 36 v1 whole square divided by 2z. So after calculation you will get 9 by 16. Or here also that is your divided by here divided by 144. 144. Then after calculation you will get this the under whole square, remember. Then after you will get this one after the calculation. Okay, let me just show you the calculation. Or you can go through that also. That is a 75% of the v1 divided by like that. So you will get the formula. You will get the answer. Okay, the next question is this. Question number 12. That is the you have the total question 12 here. So this is the previous to previous question of NPTEL hydraulic engineering. So here the first question is you just read. So I'll take the 5-minute break here. So if anyone want to take the break, you can also take. Otherwise, you try to solve the question number first. After that, I'll discuss after 5 minutes. Okay. So the first question is, so anyone? Okay, first D you are telling the option number D. Okay. So Abdul is telling D, Bhav is also telling D. Okay, the question is what is the formula for determining the size of equivalent pipe for two pipe length L1 and L2 and diameter D1 D2 respectively, where L1 is equal to L1 plus L2. So here let me just discuss. Here L1 is equal to, let me just take the pen. L1 plus L2 is given, means what? That is the total length is equal to, this is, let us suppose L1 and this is L2. So total length is L and water is flowing in this direction like that. So L is L1 plus L2 means series. In case of series, whatever the discharge here will enter, the same discharge will come in this pipe. So Q1 is equal to Q2. But head loss, the total head loss will be the head loss due to this and head loss due to this. HL1 plus HL2. The total head loss. So here, so you need to calculate this. That is the relation between L by D, that is the L by D form. So head loss FLV square by 2GD equal to FLV square by, or let me just convert the V by in terms of A, because in terms of discharge FL V square means Q square divided by A square, that is pi by 4 into capital D square 2GD, means here is D square FL V square FLQ square divided by 2G D to the power 5 and pi square 4 square, like that. So here you have the relation is, here you have the only variable D and L. So I'll write only here D and L. So HL is equal to H1 plus H2, HL1 HL2. So L by D to the power 5 is equal to L by, or L1 here, small d to the power 5 plus L by small d to the power 5. Here is 2, here is 1. So hope everyone got it. So this was, you try to need to calculate. So option D will be correct here. Okay, now we'll move on the next question. Now this is known as the Dupit's formula, remember please. The next question is, oh, answer here is visible. So the question is, in two pipeline of equal length and diameter 20 centimeter 30 centimeter are connected in parallel between two reservoirs. Connected parallel connection. Remember please, if the friction factor F is same for both pipe, the ratio of discharge in the larger to smaller pipe. You have two pipe, that is the discharge in 20 centimeter and discharge in 30 centimeter. So here the question is, find the if the friction factor is same for both pipe, the ratio of discharge in larger to a smaller pipe means Q30 divided by Q20 you need to calculate here. And the connection is parallel. You know the two conditions. In case of parallel, your head loss is equal, but discharge will be sum. Means total discharge is equal to Q20 plus Q30. So here just I want to show you how you will calculate. So you have this equation, that is the head loss in two pipe will be equal. So FL Qn square divided by due to the power 5 whatever we have calculated already, and here after the calculation pi square by 4 square, so 12.1 is equal to FL Q square divided by 12.1 due to the power 5. So after calculation, so here Q1 means 20 centimeter, that is a Q20 and Q30. After that you can very easily calculate Q20 by, here Q30 by Q20 is equal to 32. This is a calculation only. So here 32, but the answer is C. How? Here is written Q2 by Q1 is 32, but here answer is this one. So let me just calculate. Maybe the calculation mistake. Let me just take. So 30 by, okay, power 5 square root. Yes, option C will be correct, not 32. 2.75. Okay, we'll move on the next question. Question number 3. What is the aim of pipe network analysis? To determine the mass of the fluid, to determine the volume of fluid, to determine the flow rate and pressure drop, to determine the cross section of the pipe. Which option will be correct? A, B, C, D for question number 3. Everyone please try to participate. Okay, Manoj is telling C, Abdul also telling C. Other student please. For question number 3, other student please also try to contribute. For question number 3, Okay. So Vedya is also telling C. What is the aim of pipe network analysis? Yes, you all are correct. So definitely, we mass determine the mass of the fluid. This is not volume. Also, we not try to calculate, and the cross section also not. So definitely, option C only remaining. Next question is question number 4. The what are the assumption made for a fluid flow through a pipe? What are the assumption made for a fluid flow through a pipe? Fluid inertia is not taken, viscosity is not taken, volume is not considered, mass is not considered. Which option will be correct? For question number 4. Okay, option D. Manoj and Abdul both are telling option D. Mass is not considered. Okay. Abdul also telling D option. Okay. So here the assumption. The 4 option is given. So option A. So here the assumption is the fluid inertia is not taken. Mass we considered, volume we considered, viscosity also considered, but fluid inertia is not considered in case of pipe flow. Now the next question is question number 5. So please wait 1 minute. Okay, let us discuss. So here the next question is the liquid flowing through a series of pipe can be taken up. Pipe of different diameters, pipe of same diameters only, single pipe only, short pipe only. Which option will be correct? The liquid flowing through a series of pipe can be taken up. Series of pipe. The pipe of different diameter, pipe of same diameter only, the single pipe only, and the short pipe only. If you want to make a series of pipe, which type of you need to select, the that is the diameter of the pipe, how you will select, any type of diameter you can select, or single pipe, short pipe, or only same diameter pipe. This is the question. For question number 5, please everyone. Okay, I think Abdul and Manoj is telling A option for question number 5. Other student, please also try to write your answer. For different diameter we can take, yes, we can take the different diameter, because as you have seen in the previous questions, we have solved the diameter d1 d2. So definitely d1 d2 means what? The different diameter. So just this is a logical question. Now we'll move on. The next question is question number 6. The total head loss for a system is equal to pipe length, pipe diameter, width of the reservoir, and the height difference of reservoir. The total head loss for the system is equal to, okay, 36. Option D, everyone telling to D, the height difference of the reservoir. Yes, you all are correct. For question number 6, option D will be correct. Yes. Now we'll move on the next question. Question number 7. What is the total loss developed in a series of pipe? What is the total loss developed in a series of pipe? Sum of loss in each pipe only, sum of local losses only, sum of local losses plus the losses in each pipe, and 0. Which option will be correct for question number 7? Okay, Manoj is telling C for question number 7. Series of pipe we are talking about here. Sum of loss in each pipe only, sum of local losses only, sum of local losses plus the losses in each pipe, the series of pipe. Option C, okay, Manoj is telling. Other student, please also try to write your answer. Everyone, please. Okay, Abdul is telling C, Bhavesh is also telling. Oh, Abdul is telling A, Bhavesh is telling A. Okay, sum of losses in each pipe only. Okay, the total loss we are talking about here. Other student, please also try to write your answer. So many students join. So everyone, please try to participate. In basic question, very basic question. So actually I need the answer from all participants, please. Maybe you wrong or correct, doesn't matter. But first to try to write your answer. Okay, C is right. Okay. Abdul is telling C. Okay, he has changed from A to C. Okay. Definitely. The we are talking about here the total loss. We are talking about the total loss. So definitely in the pipe loss and whatever the local losses means the bend loss and the elbow loss, that will also consider here. What is the description if you want to see here? When the pipe of different diameter are connected in series from in to in of the pipeline, the total loss so develop is equal to the sum of local losses plus the loss in the pipe. The local losses are developed at the connection point. Remember please. Very important question. So here is the coefficient of friction of laminar flow is coefficient of friction for laminar flow. Many times I have discussed in the previous classes also. So here I need answer from all sides. All participants try to write your answer. Option C telling Manoj and Abdul also telling option C for question number 8. Other participant also try to write your answer. Other student please try to write your answer. Please everyone try to write your answer. For question number 8. Very basic question, fundamental question. Okay, let me discuss. So here question is the coefficient of friction. So already I have told you the coefficient of friction is, and the relation of coefficient of friction and coefficient of factor, whatever you know the Darcy-Weisbach formula, FLV square by 2ZD. So this F is coefficient of this, the factor, coefficient factor, or factor coefficient you can say. But this, the formula of your the coefficient of friction is for calculating in the laminar flow is 16 by Re. If I represent the coefficient of friction with F dash, but coefficient factor how related? 4F dash. So sometimes in question at the place of coefficient friction, the the question will be like that, you need to calculate the coefficient factor or factor coefficient. That time you will apply this 64 by Re. How? 4 into 16 by Re. So definitely 64 by Re. So remember please, you should never confuse with this the between the coefficient of friction and factor. In some problems also, maybe the gate exam or your final NPTEL exam, you maybe remember the terminology, whether they're asking about the friction, whether the value is given for friction or friction factor. Always remember that is the friction factor, not friction coefficient. I think friction factor is the term. Okay, we'll move on the next question. Okay, here is question is visible, answer is visible also. The minor losses may become dominated for a pipe of length that is a small pipe. If your pipe is small, then minor losses will be dominated. Why? Because your major losses depend on FL, V square by 2G D. That is, whether your pipe is small or whether your pipe is long, the velocity factor, that is the friction factor, diameter G and 2 will be the constant for both. If this is, let us assume 50 centimeter and this is 50 meter, both will be the same. Everything will be same, only length is fluctuating. So your h is, in such case, in this case, is related to L. So if, let us assume 50 centimeter, but let us assume here is some entrance, some exit point, some elbow joint is there. So in due to this, the small, that is a loss, the minor loss will be more, that is the dominated in case of small pipe. Remember please, because as I have discussed here, the reason is this. Okay, the next question is, here also you can see the minor losses are minor compared to the friction losses in long pipelines, but for the pipeline of shorter length, minor losses may be dominated cause of the head loss. Cause of head loss. Okay. In pipe network, the algebraic sum of discharge around each elementary circuit must be zero. The head at each node must be the same. The option second is talking about head. Option third, the algebraic sum of piezometric head drop around each elementary circuit unit is zero. And option D, the piezometric head loss in each pipeline of circuit is same. Which option will be correct for question number 10? Everyone please try to participate and try to write your answer for question number 10. Everyone please. Okay, the Manoj is telling option A is correct. Okay, for question number 10. Okay. Other participants also try to write your answer here, please. The algebraic sum of discharge around each elementary circuit must be zero. Okay, Bhavesh is telling C. The algebraic sum of piezometric head drop around each elementary circuit is 0. Okay. Other student, please also try to write your answer. I think in the previous questions, that is the hydraulic NPTEL course, NPTEL assignment, previous NPTEL assignment today, we have solved this question, I think, but the question was in different way. Here is option in different way. Okay, Abdul is telling A option, that is the algebraic sum of discharge around each elementary circuit must be 0. Okay, let me just discuss. Yes, option C is correct here. The algebraic sum of piezometric head drop means head loss, head drop around each elementary circuit V0. The option C, the algebraic sum of piezometric head drop around each elementary circuit V0. The previous questions also we have seen, I think, just if I want to show you, I think the first question was about this. Yes, here. In network of pipe, the head loss around each elementary circuit must be 0. Here also talking about the same thing. The head drop means what? The head will be dropped due to the loss only. So this was the connection. The next question is question number 11. For laminar flow through a circular pipe, the maximum velocity is equal to 1.5 times of average velocity. The maximum velocity is equal to 2.0 times of the average velocity. And option C, the maximum velocity is 2.5 times of the average velocity. And option D, none of the above. Which option will be correct for question number 11? So please everyone try to give your answer. Okay. Abdul is telling B option. Manoj is also telling B option. Okay. That is the maximum velocity is equal to 2 times of the average velocity. Okay. Other student, please also try to tell the answer. You can write in the chat box. So this is the very famous question from the pipe flow. So always remember, please. Okay, let me just discuss. So in circular pipe, you know already the formula is, or that is the velocity profile is parabolic for laminar flow. So here is talking about the laminar flow, yes, circular pipe. So average velocity means, the average velocity means everywhere velocity will be same. Here everywhere velocity is changing. Here is magnitude, let us suppose 1, here is 1.5, here is 2, here is maybe again 1, and here is 1.5, and here 1, and here 0. So like that changing, but average velocity means everywhere velocity will be same. Even at the surface, that is the at contact point also, you need to consider the this one, that is the velocity magnitude. So this is your maximum, this one u max, and this is u average. So the relation for circular pipe, remember always, u max is equal to 2 times of u average. The option C, option B will be correct. Sometimes the question asks about the parallel pipe, parallel plate. So here u max is equal to 1.5 times of the u average. So remember please. Next question is question number 12. Okay, how do we determine the total discharge through parallel pipe? Add them, subtract them, multiply them, and divide them. This is the last question for today's session. So everyone please try to write your answer. Okay, Abdul is telling A, Bhavesh also telling A. Everyone please write your answer. Maybe wrong or correct, doesn't matter. Okay, Manoj also telling A option. Add them, okay. Total discharge. I have discussed in the previous questions. Just few minutes back. So please, I need answer from all participants. A option, okay. Other participants also try to write your answer. Okay. Okay, Gopal is also telling A. Good. So here, as you know, we are talking about here the parallel pipelines. So parallel pipelines, you know already, if the water is flowing like that, your pipe is divided in two pipes. That is pipe 1 and pipe 2. So here is, if water is flowing Q, not Q1, capital Q, and here is going Q1, and here divided in Q2, again here Q. So how, here water is divided in two parts. So how you will get Q? When you will add these two things, Q1 plus Q2. But in case of series, let us suppose pipe is, here is 2 meter diameter and here is 1 meter. So whatever the discharge here is coming, that discharge only going in this. So here is whatever the Q value, here the value will be the same of the Q. Maybe velocity will increase or decrease, this is a different thing, but discharge will be the same. So in case of series pipe, Q will be same, but in case of parallel connections, your Q will be equal to Q2 or Q1 plus Q2, you can say. So that's all for today's session. So we'll meet again in the next session. Option A will be correct here. Yes, definitely. So we'll meet again in the next class on next Friday. So thank you all. Good night.
Thank you,
So
sir.
thank you so much. So now you can leave. Everyone, please leave the class. Thank you. Thank you, Manoj. So everyone, please leave the class.